The focus of this lesson is on taking an equation and graphing it by plotting points. And so in order to do that, I'm going to go ahead and just kind of write down my t-chart that I use whenever I'm graphing by plotting points. So I write down x and a y side, and then usually the y side is given as far as the relation that is present, and so y relates to x by the fact that y is equivalent to the square root of 9 minus x. Then typically what you do is you go ahead and pick your x's and then try to solve and find the corresponding y's. Well, until you get a little more comfortable with equations and functions, sometimes it's a little more difficult to pick x's that work. So when you pick your x's, you want to pick ones that are within the domain of your function, and all that means is if I were to plug them into my equation, they would give me a real number back. So they wouldn't give me something that's undefined back. They'd give me actually a value back, a real number back. And so technically you can pick whatever domain. It doesn't have to be the values that I'm writing down. But I intentionally pick these particular x's, so I'm going to go ahead and work with these. So again, think about what's going on when you're graphing an equation. It's made up of an infinite number of ordered pairs. Well, we already picked the x-coordinates of those ordered pairs, and we're trying to determine the y-coordinates that correspond to each of those x's. So, all you do is when x is -7, y is the square root. So I'm going to go ahead and write down the square root, but instead of writing the x, I'm going to put in my specific value, which is -7. And maybe I'll change colors to kind of show that. But I'm just going to kind of show the pattern going down as far as what that looks like. But notice how I'll always have my square root of 9 minus a value, and that value is going to be the x that I pick. So it's a specific x. I'm putting in a specific x for that general x. So again, I'm just going to kind of write it all the way down, and then I'll just kind of maybe plug in my x value in blue so you can kind of see what happened. So my x value in this first case is x is -7, in the second it's 0, in the third it's 5, in the fourth it's 7, fifth it's 8, 9, and 10. So that's all. And what we would do is we would simplify that result. What is the square root of 9 minus a -7? Well, 9 minus a -7 is 16, and the square root of 16 is 4. So this gives me the ordered pair -7, 4. The square root of 9 minus 0 is the square root of 9, which is just 3. So that gives me the ordered pair 0, 3. 9 minus 5 is 4. The square root of 4 is 2. That gives me the points 5, 2. And since we are dealing with a square root, if you pick different x values, it's possible you don't get a whole number value for that y, but that's fine. 9 minus 7 is 2, and the square root of that is the square root of 2. So that's a good example just to kind of convey that. So that's 7, square root of 2. And sometimes it's helpful if you write the decimal form, so that way you know where it falls graphically. I know it's going to be 1 point something, so that gives me an idea. It's somewhere between 1 and 2. 9 minus 8 is 1. Square root of 1 is 1. So this is 8, 1 is an ordered pair on our graph. 9 minus 9 is 0. Square root of 0 is 0. So that gives me the ordered pair 9, 0. 9 minus 10 is -1. The square root of -1 is undefined. So this is undefined, meaning 10 is not in the domain and shouldn't be a value that I pick. So, and actually everything bigger will also be outside of the domain. So this doesn't actually give me a point back. So I just wanted to show how that can happen. If you pick some x's, sometimes they don't give you a real value back because they're outside of your domain. And so then it just boils down to, can you plot each of those points? So negative 7, 4 would be here, 0, 3, 5, 2, 7, square root of 2, which remember square root of 2 is somewhere between 1 and 2, 8, 1, oops, I actually meant to go here, sorry, 8, 1, and then 9, 0, and then anything beyond 9 is outside of our domain, so there's no graph on that side of 9. So then I go ahead and I connect all my points, and you know, it might look like that's all there is, but technically I could have picked values smaller than negative 7 and they would have worked. I would have got a real number back. In fact, it would have gave me a real number that continues to increase as we go negative. So that's what my graph looks like. It's like this little, that's what a square root looks like, that kind of shape. So it's not a perfect drawing, but you get the idea. And then there's no graph towards the right of 9. Now I'm going to ask a couple of follow-up questions just to kind of see if I have an idea of what's going on graphically and point-wise. The first is 0, 9, a solution to your graph y equals square root of 9 minus x. So if you look at your graph, if it's a solution, it should fall on your graph. If it's not, it will fall off of your graph. It'll be somewhere else. But if you look where 0, 9 falls, 3, 4, 5, you can see that puts a point up here, which is nowhere on our graph. So the answer, just from a graphical perspective, is no. You can see that it in fact isn't. But you could also determine that algebraically. You would take your equation, and wherever there's an x, replace it with your x value, and wherever there's a y, replace it with your y value that you're trying to test. So my y value is 9 and my x value is 0. Left hand side I get 9. The right hand side, 9 minus 0 is 9, but you're taking the square root of that 9, which is 3. So does 9 equal 3? And the answer is no, those aren't equivalent. So that means that 0, 9 is not a solution to our equation. Another piece of information we can ask about is the x-intercepts and the y-intercepts. And if you remember, I talked about those in a prior video, but that's where your graph intersects the x-axis and the y-axis. So we can see that the graph intersects the x-axis at the ordered pair 9, 0, and it intersects the y-axis at 0, 3. So the x-intercept is 9, 0, and the y-intercept is 0, 3. And it's possible to have more than one for each, recall. But that's just other pieces of information you can glean from the graph after you graph it.